Okay.
Hello, everybody. I just wanted to make sure that we recognize this is all in the interest of science, specifically chemistry, which we all know is the study of matter, its properties, and the changes it undergoes. So we're going to see an example of said matter. So first thing I want my crowd to tell me. Bit of matter right here. What is the phase of this bit of matter?
It's an...
Oh, nice job! The 8-year-old's got it. So that is a physical state of matter, right? So it's a physical property of this stuff. I know it's in a dark bottle. You want me to pour it? Probably shouldn't. So anyway, this is methanol, and what we're gonna do once it gets a little bit darker is we're gonna add some methanol to this big giant car buoy, and then like any good chemist, we're gonna light it on fire. Right? So what I'd like you to think about before we do this is I would like you to predict exactly what you're going to see, hear, smell, probably shouldn't taste it, and I can't remember the other sense, touch, don't touch it either, right? So that's what we're going to see in just a little bit. Are you all ready to, I want to hear your predictions. I want to hear specifics. That's not enough. It's going to be white. It's going to be white. Okay.
Green. Green. I think green.
Green. Okay.
Red.
Okay, what are you going to hear? You can hear a boom. Anybody else?
A fizzle.
A fizzle.
Oh yeah.
Anything else? Kim, anything?
No.
You got nothing? Okay, I think we covered all the bases. What are you going to taste? No, don't do that. Okay, so I'm going to do something really interesting, right?
No, put your glasses on.
We saw this liquid. Safety glasses are to protect your forehead. Okay. So what phase was this, Audrey?
Liquid.
Liquid. So I'm going to do something really odd here, right? I'm going to pour a bunch of liquid. Is that enough?
More.
Gotta pour more.
Big explosion.
Right? So I'm going to do something pretty odd, right? I'm actually going to pour this out. The first, I'm going to do a little swishy swashy. Okay? So I'm doing some swishy swashy, and then I'm going to pour it on my wife's foot.
No, get back. Oh, God.
Right? I'm going to pour it all out. Is your prediction holding? You still think you're going to see what you thought you were going to see?
I don't know.
No?
Gold.
Well, let's see.
Yes, give me an
Why? Tell me why.
No idea.
Perfect. What?
It's a gas.
Oh my God. She's taking the wind out of my sails with correct answers.
Yep, it's changed.
Give me a count of 3.
3, 2, 1.
Oh no.
It's green.
So what do you think?
That was amazing.
That was
What's going on?
cool.
What's going on right here?
It's taking the air out of it.
Oh, crazy. So we saw gas,
Yes.
right? We hit it with a little bit of flame. What kind of change was that? Was that a physical or a chemical change?
Chemical.
Chemical change. How do we define a chemical change? Wife?
Fire.
It was a reaction. The state of
Okay.
matter is different now.
Yes, exactly. Well, it is
Not the
necessarily
state, not the state, the
but
state.
the actual chemical bonding between the products is different than it was in the reactants. What is that? Do I have to light that on fire? I don't think this thing works anymore. Here. No, this is a
Oh, we
different
brought
one.
some. Yeah, I think ours are pretty dead.
Here. Come here. Oh man, everything's dead.
Am I still filming?
Yeah, still film. Okay, but any good experiment needs to be repeated, right?
Yes.
Okay.
Do it again.
So we're gonna do the exact same thing again.
Audie, in a minute.
We're gonna pour more in there. And we'll do the same thing. Right? 1, 2. Notice the difference?
Yeah.
What was the difference? Yes, class?
It didn't go even farther up. It didn't go boom.
It didn't go boom. Exactly right. Why do you think that is?
I don't know.
What's actually going on in terms of what's required for this reaction? We saw methanol, right? So methanol vapor, but what are we doing right now? It needs air. It needs specifically what in the air?
Oxygen.
Oxygen. So what we did was we just converted everything to carbon dioxide and water.
And we didn't put more
Right.
oxygen
There's
in.
not enough oxygen. So it went a little slower. Demo over.
Hey Chem 112, this is a bit of a test video, so you can let me know if this thing works, if you can see what I'm writing on the board or not. But I'd love to have the chance to kind of do a little bit more of a, what I call a chalk talk session. One thing I should mention is that at my house there's all kinds of craziness going on, so if you ever hear dogs barking or people yelling or music playing, I'm sure you probably have something similar happen in your house. I'll do my best to edit that stuff out, but hey man, it's real life. So anyway, hopefully you just saw one of my favorite demos to do, which I call the whoosh bottle. I just wanted to talk about 3 different ways that we can understand chemistry. So 3 ways to understand chemistry. Keeping in mind the definition of chemistry, that it's the study of matter and its properties and the changes it undergoes, you actually saw all of those things in the demo, the whoosh bottle demo. So there's kind of one understanding, which I call the macroscopic understanding. And that's kind of the big thing that happened, right? And so I'm going to kind of draw what's kind of like a chemical sentence. It's called a word sentence. And regarding the bottle, the whoosh bottle that we just saw, what we're going to see is that we have some sort of methanol. And I had to add something. And that methanol underwent a chemical change and eventually went to carbon dioxide plus water. This is a really common type of reaction that we're going to see here. It turns out the thing that we need to add in this position is actually oxygen gas. This is a typical combustion. This is the same combustion that happens in automobile engines. At least we're probably not running methanol unless you're a drag racer. But that's pretty much the point of this fuel combines with oxygen gas. We get carbon dioxide and water. And writing it out like a sentence like this helps you to see why the second time I tried to do the experiment, it didn't work. Because what happened was all that oxygen gas went away. And there was only carbon dioxide and water vapor that were actually in that container. And so it didn't have one of the reactants. And so I wasn't able to successfully do the whoosh bottle again. All we saw was probably a little bit of flame at the very top if you were looking very carefully. And that was the methanol that was burning at that air interface where there was no carbon dioxide at the very, very top. So that's what I call macroscopic. Macroscopic is kind of like the thing we see with our eyes, or the big thing that's happening. It turns out that there's also what's called the microscopic understanding. And we're also going to draw a little sentence here. And we're going to talk about what exactly happened at a microscopic level. When we get to day 2's lecture, we're going to talk a lot about the particle understanding of matter. And so the microscopic understanding, what we would do is we would start off with some sort of methanol. And methanol has 1 carbon and 4 hydrogens and 1 oxygen. Let me grab a different color here. And so we could have maybe a microscopic understanding of what happened by saying that that's now going to represent methanol. And don't worry too much about the structure, and don't worry about the fact you probably can't see it very well. But the important thing is that we have some oxygen gas floating around in there. Right? And when you get to day 2, you'll actually start to be able to call these things diatomic elements. And this thing is obviously a compound after you look at that day 2 lecture. It's actually 1, 2, 3, 4, 5, 6. This is a hexatomic compound. And what's going to happen after we undergo a chemical change, we can understand the microscopic change in that we've actually changed the bonding situation of this thing. And you're going to notice that the number of red spheres and blue spheres and everything else don't really balance out when I put my products up here. We're going to take care of that probably in week 2 when we start talking about balancing chemical reactions. So don't worry about the fact right now that it looks like I'm missing spheres or gaining spheres. We're just kind of talking about the way we started and the way it looks at the end. So what we end up with at the end, if this thing is representing oxygen gas, these 2 blue spheres, the fact that I formed carbon dioxide is going to be shown to me like this, right? And so there's carbon dioxide, and I know I formed water. And so microscopically, what I've essentially done is I've taken something that used to be this mixture of oxygen gas and methanol, and I've totally changed the bonding environments around those different spheres, right? And I actually ended up with 2 new compounds, as we'll learn to call it in day 2. That's carbon dioxide, and that's water. So when you go from macroscopic to microscopic, things get a little bit more difficult to understand. And that's really where a lot of, we're going to spend a bit of time talking about this particle diagram of matter. We're gonna try to, especially in day 2 and a little bit in day 3, try to make sure that people feel pretty good about representing and classifying these different kinds of compounds and elements and mixtures and things like that. So once you've kind of gotten this microscopic understanding, it starts to make a little bit more sense when we start to talk about the symbolic representation of matter. So the third representation of matter is going to be symbolic. And that's my son yelling and screaming upstairs, so hopefully he's still alive when I get up there. And I guess I didn't put a 2 here, but you understand. So symbolic representation, well, here's the microscopic representation. I'm going to write the symbolic representation under here. And this is the one that we're going to kind of work towards understanding, right? And this is truly the way that a chemist would understand the combustion of methanol. Right? And so it kind of looks a little bit strange, right? It's a bit of a way of kind of keeping track of everything, right? And you see the symbolic form, and this is kind of what's in your mind in a microscopic sense. And you also have to keep in mind that macroscopic look at things. Other things, just to make this look fancier, since all of these things were in the vapor phase, often you'll see this little phase designate added at the very end of our whoosh bottle, that there was some liquid water floating around. So this is what that sucker looks like in a symbolic representation, and it all kind of is from this microscopic understanding of matter. And again, this is not something you're going to understand today necessarily, but I'm hoping to kind of just introduce things gradually here so we can start to understand. I can tell that I got to kind of make sure that I'm not sloping off into the ground here. Apparently my guitar amp is big enough that, I'm a big rock star, right? I mean, obviously. So I think my guitar amp has like a bunch of gravity and it's pulling everything down over there. But anyway, I hope that kind of helps to explain a little bit of what you saw in that demo. Also adds to your understanding of chemistry just a little bit.